see my screen?
Yes, the screen is there and your voice is loud and clear.
Okay, fantastic. So cool. Thank you very much, guys. Tuning this launch and learn session. For some of you probably met me before, you will see a little bit difference. I'm actually wearing a mustache, a real one, by the way. It's okay to laugh. I know it looks funny, but I'm actually doing that for a charity event. So just putting that out of the way, I got asked just now. So in the session today, we're going to talk about continuous compliance for infrastructure in the cloud. Okay. In this session, what we're going to do is to introduce an open and a modular reference architecture that you can take away today and apply in your organization or in your own work. And just to spice up the reference architecture kind of talks at the end of this session, I mean, second half of this session, I'm going to throw in some demos and I'm going to show you some code. And for some of the geeks on the call, you'll be excited. For some of the other people who are probably not interested in coding, that's fine as well. I'm going to show you how it's working in the Google Cloud environment. So without further ado, let's get started. So first of all, I like to bring you to the concept change of doing security in the cloud. And I still remember not many years ago, probably about 5 years ago, I was talking to a group of a CISO traditional enterprise. We talked about, hey, your perimeter and how do you secure your environment today, and how important it is to have perimeter, that kind of stuff at a time. And sure, um, the perimeter heavy kind of security control. I think most of us are very familiar. And so I actually walked past one of the car park next to where I live in Hong Kong. And so if you look at the left-hand side, the photo I've taken for the car park, you can sort of thinking about how perimeter security often is executed in most of the enterprise here today. So you have boom gates at the perimeter. So things can come in or leave that perimeter based on some of the rules you set on the boom gate. But this particular photo is actually very representative as well. As you can tell, there's a massive gap between two boom gates as well. So sometimes, probably most of the time, your perimeter control isn't that robust. And there are things can come in if they're not a car. And sometimes when we get into the perimeter inside the car park, there's free roaming, east and west traffic, often not very controlled. And that's how we do security before, because of all the constraints, etc., etc. We're not going to talk about that. We want to talk about the new world. So the bottom right hand side, we have the guardrails. We have the highway kind of driving. So I like you to remember to bring up your recollection of driving on a freeway or highway. Depending on where you're from. There's no rules. You don't have to. There are rules. There's no stops. You don't have to stop and start on the hard freeway. And statistically, the accident rate on the freeway is actually lower compared to the normal roads. So how could you go fast at the same time be more secure? So let's try to unpack what we can learn from being the freeway, which is the guardrails that builds up part of the freeway. And if we're talking about, since we're talking about compliance today, and security and compliance go hand in hand, but security doesn't equal to compliance, and vice versa, compliance doesn't equal to security. I like to explain that concept using a diagram. So we have a diagram over here, x-axis representing the time, and the y-axis representing the level of security or compliance. So I have a red arrow line, basically representing the desired state of security that's defined by various different compliance frameworks. Okay, so essentially, compliance frameworks is asking for good security. First stop. And we'll have the green arrow line representing the actual state of your security in your environment. So that actually is what you have. And often at the very beginning of the compliance cycle, and we have the audit, right? And after the audit, in a very ideal world that we remedy every audit finding, great. It's very likely that your desired state and actual state overlap. Fantastic, no problem. But your environment is not going to be static. You are going to introduce new features and everything into your environment. And the gap between desired state and actual state will actually increase. And most of the security team actually understand the existence of the gap, but sometimes they don't understand, they don't know how big the gap is until next audit comes in and becoming a problem to be fixed for the next audit. Even then, as we all know, sometimes audit can be flawed as well. You have auditors coming in with a spreadsheet, they're trying to tick off all the boxes, asking you for screenshots, etc. The usual auditing process. So again, that's probably not good enough. That's the usual problem introduced in the whole compliance and auditing kind of processes. In the cloud, though, what we want to do is to realize something like this diagram is a much better version of a previous diagram, okay? There are a few things happening over here. So first thing is you have some preventative controls preventing bad things from going into your environment, okay? Now, beyond that, you will have to have a continuous monitoring process looking at if you have anything that's all of a sudden becoming non-compliant. And once you pick up anything that's non-compliant, you want to have automation in place as well to bring those non-compliant resources back to the compliant state. Okay, so all of those can be realized in the cloud. Why? In the cloud, almost everything is an API call. If everything is an API call, you can actually open up your imagination to use different type of automations and serverless functions, etc., to bring that into life, which I'll show you later on. So with that, I'd like to introduce the main topic of the session today. We're going to talk about a reference architecture. Again, like at the very beginning of this session, I'll talk about this particular reference architecture. It's open, okay? It's also modular. What that means is it doesn't only apply to Google Cloud Platform. It doesn't only apply to cloud. It can actually apply to on-premise as well. Just to realize those automation can be a little bit clunky if you run entire thing on-prem. So let's get started. With that, we are trying to use the example of an infrastructure engineer. Could be me. So it's me, Ken. I'm an engineer. I'm writing the infrastructure as code, such as Terraform. Okay, I'm writing Terraform code to build my Google Cloud Platform, and often I want to use a continuous integration system to orchestrate my infrastructure as code, my Terraform. On that, I can build something called a unit test. For some of the developers on the call, you will know when you write a code, you probably want to write a unit test to test whether the code is actually functioning as per designed. Is a similar concept. We're going to write security unit test, okay, acting as a policy evaluation. Over here, if my code passes a unit test, security unit test, it will go. But if it doesn't, it will fail. And at the same time, my CI system should give me feedback telling me, Ken, by the way, your code has failed. Here's the reason why, and here's another set of recommendations you can do to fix your code. So with that process in place, over time, I will actually learn how to write better code, right? Because as an engineer, I don't like my code to be failed by CI all the time. Over time, I learn. Consciously, unconsciously, I learn how to write secure code. If everything goes fine, no problem, it's going to be applied and build the infrastructure in the Google Cloud Platform. On the right-hand side, though, we're going to have exactly the same set of policies, but this time, instead of using continuous integration to look at the policy evaluation, that kind of stuff, we're going to use some of the cloud-native services or some third-party services to take that same set of policy and continuously scan our cloud environment, looking for if there's anything that's violating the policies of the set. If he doesn't find anything, fantastic. It's going to give me feedback telling me, hey, Ken, I didn't find anything that's non-compliant. Fantastic. Some people may ask a question over here. Hey, Ken, you've already controlled everything from the left-hand side. Why do you need to have a scan on the right-hand side? In theory, there's nothing non-compliant should come to an environment, right? Correct. But that's also very important for your right-hand side to have continuously scan of your environment, because every successful scan comes with a report, and every scan report comes with the timestamps. And timestamp of a successful report will be very, very important for you to present to your auditors. And that can save you lots of time and money. And I think probably for some of the people who want to auditing processes, most time-consuming part is to organizing those evidences in the order, in the way that auditors can understand. So with this automation in place, you can have confidence at any time presenting a compliant version of infrastructure scan to your auditors. Obviously, if it finds anything that's non-compliant, it's going to spit out an event. With that event, you can then trigger something like automatic remediation, for example, to go back to the environment, pick it up, change it back to the compliant state. To enable the entire workflow we're looking at here is this reference architecture. So I'm going to take you through the thought process of this reference architecture. There will be quite a lot of information. You don't need to remember all of them. Obviously, we have a recording in place. Harry is kindly recording his session, so you can always refer back to it. If you like to, you can take a screenshot. Choice is yours. So, 4 core components for this reference architecture. We have 4 different types of controls: directive controls, preventative controls, detective controls, and responsive controls. Let's starting with the directive controls, which is the first half of the diagram. With directive controls, the core and the heart of the directive controls is GCP Technical Control Library. So people will ask, hey, what that is. That's a new term I've heard. You can think that is a control mapping process. So you can envision the control library look like a massive spreadsheet. Okay, on the left-hand side, you have all your compliance requirements from different sources, which I'll show you later on. And on the right-hand side, you have the controls you can actually implement in Google Cloud Platform or any cloud you want to use. So that builds the lineage between the compliance world and the actual cloud world. And it can also rationalize, why do you do some controls in your cloud environment? Which particular compliance requirement it is addressing. And that's very important, again, first, to help you to rationalize your security budget, your security efforts, and also make the auditing, again, a lot easier. We're talking about auditing and the compliance languages here. So there are different things you can consider to build your control mapping technical control library. These are the probably more representative ones. We have the threat landscapes of a particular industry. So you may have, FSI in Hong Kong, or you may have the manufacturing in Taiwan, etc. And you will have your own, if you're working for a massive company, you will have your internal risk governance processes, and you also will have your internal security policies and standards, etc. And you can also take industry best practice as part of your mapping process. So most frequent or most popular ones we've seen people doing will be CIS, foundational kind of security benchmark for GCP, AWS, or Azure, etc., etc. And on the right-hand side, obviously, one is taking your compliance requirements for your regulators as well. So bring those all together, thinking about a spreadsheet again, compliance requirements, and what you can actually do in Google Cloud to address those compliance requirements. That builds your technical control library. And that already sounds like a very daunting task, right? I know it is one thing you have to get right to begin, but also it is also something you don't have to sweat about. Why? Because you don't need to build an entire massive spreadsheet before you start doing anything else. It's iterative kind of approach. You wanted to probably start with something very important to you and get it right and move on to the next. Because this control library is going to be a living documentation. It's not going to be like a one-off and you stop, that kind of process. Now, once you have the control library, what's going to do is going to dictate or guide the remaining of the controls. For instance, the workflow we looked at just now, me, infrastructure engineer, trying to write Terraform code, etc. Okay, same thing over here. If we are using infrastructure as code, pipeline as input, and we're orchestrating the Terraform code, for example, we can use what we call a security unit test, remember, to do the constraints. But also there are other sources of building your cloud infrastructure. One of them can be SDKs, okay? In Google Cloud, we have the G Cloud, We have different SDKs from Python, Node.js, etc., etc. And also you can go to the console and click and build your infrastructure. All of those are fine. But at the end of it, every single thing you do, no matter it is infrastructure as code, SDK, or console, they're all going to be API calls. And with API calls, your last line of defense next to your actual infrastructure, you can use organization policies and IAM controls. So organization policies, for people who are familiar with AWS and GCP and Azure, etc., all have similar services. You can think that as your high level overarching controls from the from your organization level. So for instance, you kind of go, I don't want any of my cloud users to deploy any virtual machines in a region that I don't want them deployed to. For example, let's say United States. You can actually set that policy at the very root of your organization, and they'll become effective. And everything underneath the root will be, you will inherit that particular policy so that you can actually apply the control once and have that become effective for the remaining of your infrastructure. And also you have IAM. IAM essentially determines what can particular identity do, what kind of permissions it has in your infrastructure. So with organization policies and IAM, you can actually control closest to your infrastructure. You can also control both Terraform, infrastructure as code, SDKs, and the console. Okay. And once you have that, it's going to build your infrastructure. Fantastic. Now moving to the right-hand side. In the Google Cloud world, we're going to use Security Command Center Premium. So essentially, it's a building a native service. One of the features, it has many features. One of the features is to help you continuously scan your environment and looking for if there's anything non-compliant, which in the demo later on, I'm going to show you Security Command Center working in action. Okay. Now, if it finds anything, we can leverage a term called event-driven architecture. Okay, what essentially says is everything occurs in the cloud. Every action is an API call, and every API call will have a response, whether that's successful, failed, or anything like that. And those events can be leveraged to trigger the next step of action. That's what we call event-driven architecture. So if a security command center finds anything that's non-compliant, that actually generates an event. With that event, you can then trigger different things. One of those most frequently used things can be a serverless function. Take that event input and do something about it. And different things you can do over here. It can be automatic remediation we talked about before. You can also use Cloud Function to send email to your operations team. You can use Cloud Function to send an instant message on Slack. Again, it's in my demo as well. Or you can even use Cloud Function to file a ITSM system ticket. You may have your existing ITSM system, and you can ask the function to file a ticket automatically on your behalf. Okay, and you can use that ITSM system to take off your remaining of your workflow. So I think this is quite self-explanatory and too obvious that why do you want to have continuous compliance? The real risk are real security, because as I've seen before, it's not perceived as security. You're going to have real security. It's going to look at the real misconfigurations. It's going to remedy that for you in the real time. Because that speed and real security actually have real reduced risks. Okay. Now we talked about before a little bit around lower the compliance audit cost. So having the control library in place, it shortens the amount of time between your teams and the compliance teams and auditors, because you have that control mapping in place. It actually bridges two different worlds together. And the last thing is the improved engineering kind of experience. I think I personally worked for and consulted for many big enterprises, and security team hasn't been the most popular team in big organizations. I think lots of people really can empathize why that is. And also developers usually think security people are just people saying no, don't understand technology, blah, blah, blah. With these continuous compliance in place, you're actually bringing those developers or engineers into the security conversation. They are part of it. and they can actually contribute to building those controls themselves. And also the workflow I showed you before, the example of me being an infrastructure engineer, I'm actually learning over time to write more secure, better code. Maybe because I wanted to learn more, or maybe because I just simply don't want to fail. I don't want my code to be failed. Okay, either way, you have uplifted security practice, and you're making engineers more involved in that practice. So that's the end of the theoretical stuff, and we're gonna start with probably a little bit more fun stuff over here. So I'm going to explain to you a demo that I've built today. Essentially, this demo is going to take up this reference architecture and apply it. Okay, so this is the application of this reference architecture. So again, we talked about 4 different parts of the reference architecture: directive, preventative, detective, and responsive. So I've chosen some hello world kind of examples over here. So for the directive controls, what I've done is I've chosen the CRS GCP foundations. Okay, that will be, I'll pick one of the controls from that benchmark to demonstrate how you can do a very simple control mapping. And then beyond that, I'm going to use the Terraform code to build something, and I'm going to use an open source solution called Checkmarks KICS, the KICS. That stands for Keep Infrastructure Code Secure. Okay, that's free of use, open source. So what this particular tooling does for you is it actually has built-in policies that's written in what we call open policy agents. That's very open. You can do a clone of their open source project and make the modifications and becoming your own. Anyways, it comes built in those policies, so it's like Tanky. Plugged into your CI, it will work. It will tell you if your Terraform code has some security loopholes or vulnerabilities. So, for example, if you deploy something that's got open architecture to the world and to the internet, that's going to tell you it don't have the right line of code. And the KICS sounds like marketing over here, but I really like this tooling. Okay, it's open source, free, so you use it. It works for GCP, works for AWS. I think it works for Azure, even Ali Cloud as well. So do Google search, look for Checkmarks KICS and see what you can find, what clouds they support. And they have GitHub repo which you can clone and do your own. And for detective controls, I'm going to use the security command center to check in my example, to check if I have something that's non-compliant. And the security command center is going to trigger that. You remember the event-driven architecture. We're going to use the security command center to trigger a cloud function using PubSub, which is the bridge of our event-driven architecture. Cool. So directive controls, very toy example. Left-hand side, I've chosen CRS, GCP Foundations 1.1. In that particular benchmark, there are several different controls. I've chosen 3.6. So in this compliance requirement, essentially, it's asking me to have a good control of SSH. It doesn't want me to have any SSH being exposed to the internet. Fair ask, right? How do I realize that particular ask from CIS GCP Foundations 1.1? I've chosen 3 places to realize that particular compliance requirements. First place is my organization policies. Over there, I kind of go, look, I don't want any of my virtual machines to have external IP addresses. Okay, without external IP addresses, it's almost impossible for me to open SSH to the world and having someone to be able to SSH into my machine, right? That's not enough. With Checkmarks KICS, it actually has a built-in policy to look at if my Terraform code has any SSH access that's open to the world. Okay, fantastic. I didn't have the right line of the code. It comes with the KICS. And at the end, we have SCC, Security Command Center. It also has a check, looks at my environment, looking for if there's any open SSH port. So these are the 3 technical controls to realize my compliance requirement that's coming from CRS. This is probably oversimplified control mapping practice, but you get the gist. You're trying to realize the compliance requirements using something you can actually do in your cloud environment. Okay. Now, For the preventative controls, we're going to use the same workflow we talked about before. From the left-hand side, we'll have my Terraform code, which I will use a Git service in Google Cloud Platform called a source repository. You can use any Git you want. It can be Bitbucket, GitHub, or anything. So I'm going to check in my code into that particular Git repository, the source repository, and I'm going to have a CI system. In Google Cloud, it's called Cloud Build. It's fully managed serverless feature. So it's going to look for if there's any push kind of event. So if I make some changes to my code and I push back to my repository, that's going to trigger an event, right? And my Cloud Build is going to listen to that event. If there's anything new pushed to the repository, it's going to run. So over here, my first Cloud Build is going to take the check marks, kicks, as the security unit test, run it against the code that's being pushed by me, okay? And it's going to then save the report, the scan report, to a cloud repository like the bucket, a cloud storage bucket, and step number 4. And if it fails, my CI is going to tell me, engineer, hey, it's failed, and it will tell me also what I can do to fix it. And if it doesn't fail, it will go to the next stage. Because when it doesn't fail, I'm going to leverage the event-driven architecture again. I'm going to use the pub/sub and send a message to trigger my second cloud build, okay? My second cloud build, very simple task. It will just go, hey, I take that event from pub/sub, and if it's a successful event, fantastic, I'm going to build infrastructure using Terraform. I'm going to run Terraform apply. Okay, I'm going to show you the coding a little bit later on as well. And obviously, like we said before, what's closest to your Google Cloud environment, to your APIs, the IAMs and organization policies. And step number 7 is going to be your last line of defense. And that basically is how we're going to do the preventative controls. Now, for the detective controls and responsive controls, we are going to use Security Command Center. Okay, Security Command Center, like we've seen before, is going to look for if I have anything, any SSH open to the internet. Okay, if it finds anything, it's going to do 2 things using the event-driven architecture. I'm repeating myself. So first, event-driven architecture from the bottom, we can see we're going to use Cloud Function with Python SDK to send a message to Slack channel. Okay, so some of you probably have your operations team having their own Slack channel to look at all the alerts. The second Cloud Function is going to go back to my infrastructure to fix it. Okay, my example over here is basically around SSH port open to the internet. So in the Google Cloud environment, it can be me trying to create a firewall rule that's open to the internet. Okay, so demo time. Okay, let me actually pray for the live demo god. So what I'm gonna do is I'm gonna stop sharing of my main screen and I'm gonna share my demo screen. Cool. So first of all, what we want to do is look at first example. Like I'm infrastructure engineer, and this is my Terraform code, a very simple Terraform code. I want to draw your attention to this few code block over here. So essentially, what this thing is trying to do is kind of go, look, I'm going to create a firewall rule, okay, and I'm allowing source range of anything, everything, 0.0.0.0/0 on port 22. Okay, what that means is I'm creating a firewall rule to allow unrestricted SSH access. Okay, so I'm probably going to make a little bit of change over here, save it. So what I'm going to do is I'm going to push this code to my code repository. So this is my code repository. As you can tell, currently it's still showing 443, which was from my previous example. So what we're going to do, we're going to go, hey, I'm going to git add, commit and push. So it detected a 1 change. It's going to push the code up to my repository. So once the code has been pushed to my repository, let's give a refresh. You can see that's been changed. And my cloud build, the first one, is actually running now. Okay, you'll probably take a little bit of time. We can have a quick look. So as you can tell, it actually grabbed kicks. See, as you can tell, KICS over here is going to run its thing. While we're waiting for it, we're going to look at another example. Okay, let's look at what else. The second part of the detective and responsive control part of it. Okay, now we're going to have a firewall section. I'm going to create a firewall. Okay, so maybe I always like to play this game every time I present this topic. So a question to the crowd: how long would you think it takes for my security command center to detect if I have created a non-compliant firewall rule, and automatic remediation removes the firewall rule? Like how much time would it take between detection and removal? You don't have to unmute yourself. You can probably type your answer, your guess in the chat window. Okay, or you don't have to type anything. Just have that number in your mind. Have a guess. Okay, now remember some of the cloud vendors, they like all of those API calls, right? Some of the cloud vendors actually have 5 to 15 minutes kind of SLA for all the events to be delivered, to be available in all the logs. Therefore, you can actually have the next step of actions. So let's do that. I'm going to put on my stopwatch as well. Let's see if I'm breaking my record today. Okay, I've got a stopwatch on my phone. So what I'm going to do is going to create a firewall rule. Let's call it bad firewall. And it's ingress, no problem. I'm going to apply that to all instances. And the source range, I'm going to go, hey, 0.0.0.0. And we're going to port 22. Okay. Let's create that one. Right. If you're doing the same thing, right, let's be fair. Let's wait until the little spinning wheel finishes its job. So, and kick off the timer. So it's still running, creating. Cool. Let's kick off the alarm, the timer. Okay, let me just refresh. It's gone. My side. It's actually less than 10 seconds, probably around 8 seconds. So, okay, it's gone. So I have created a bad firewall rule that's allowing the unrestricted SSH access, and it was detected and it was removed. Let's look at my security command center. So it picked up that particular event. This one's from this morning when I was running the test. As you can tell from timestamp, it was 9:17. And this is the one just now, around 1:05. So entire thing for security command center to pick up the open SSH port and my cloud function to remove it, it took less than 10 seconds. Okay, that's the speed. It's very difficult to realize if you're running something like on-premise, etc. So cloud actually gives you the power. So you can use the scalability and the power of the cloud to really bootstrap and to supercharge your security. Now with that in mind, let's go back to the build. Okay, as expected, my build was failed. Okay, so over here, let's see if we can make it a little bit bigger. Good, that's probably better. So over here, it's failed and tells me, hey, I found there were high or medium findings. Please remedy. Gonna go, okay, fine. What was it? So if I go up, you can see kicks. The checkmark kicks was telling me I've got a medium finding, and it actually even tell me which particular file the finding was found and what was it, and what's the description. What do I need to do to fix it? Okay, let's try to do that. I'll go back to my code. I changed that from 22 to 443. Obviously, that's not going to trigger this rule. Let's run that thing again. Cool. Let's go back to our build. You should, yes, you did, and you trigger the build again. It's going to run the kicks. While we're waiting for the second example to run, I'm going to show you some of the code. The reason why I want to show you the code is I want to show you how simple it is to actually make this happen. Okay, there's nothing daunting about a bit of YAML here and there, a bit of Python there as well. So by the way, just now, one thing I forgot to show you was my Slack channel. As you can tell, 105 also received the notification. It was telling me, hey, I found a high severity finding, and please do something about it. Cool. So first coding I want to show you is the first cloud build, the serverless CI system in Google Cloud Platform. In that, I basically just use a few lines of code. For people who are familiar with the shell, for some of the system admins, will be like your second language, it will be your native language. You'll be able to do that. Over here, I manipulated a little bit around the scan results. So I kind of go, if I find anything, I'm going to spit out a message, which you've just seen before. And I'm going to run that particular check against all my CI unit tests. And if it was successful, I want to trigger the next steps. As we've seen before, I'm going to push a message to the PubSub to really kick off my second cloud build. Okay, and here's the code for my second cloud build. Very simple. It only does two things. It does init, so it's going to initialize the Terraform environment, and second thing is going to apply that. So it's a very simple hello world kind of example. But as you can tell, less than 20 lines of code, you can actually make that happen. Now, another thing we want to look at is the automatic remediation Python function. Okay, over here, I use less than 15 lines of code. Actually, like first 7 basically importing stuff. It's not even it's less than the hello world kind of a complexity to realize that automatic deleting firewall kind of function. Over here, I'm not going to unpack it. Basically, I want to show you it's so easy because we have SDKs on Python SDKs, which you can use to manipulate the Google Cloud APIs. So it's basically wrapped. It's wrapped in front of normal APIs using Python, and people can use that. Or people who are familiar with Python, they can easily use that to write it on the functions. And also we have a Node.js and other things as well you can use to write your own. Okay, it's very simple. So let's come back to the cloud build. Let's look at the process, see how it goes. Oh, it's still running. It should be finishing very soon. So over here, let's look at this one first. This is my scan. Kicks got triggered, and it didn't find anything that will fail my build. Okay, the previously medium finding is gone. So it actually triggered a second cloud build. And over here, we actually have a second cloud build failed. And why is that? We can actually look at the logs over here. Okay, it's telling me I actually have my previous example I had in this morning. I didn't get a resources I deployed remove it, so I have some conflict with that. But again, the gist is, with that change, you can actually chain all the cloud builds together. You can choose to chain even more cloud builds. You can have more complicated logics they can build using this particular kind of workflow. So with that, I'm going to go back to my presentation. I still have a little bit left for you that you can actually take home. So with the demo, I hope you enjoyed it. I enjoy it every time when I run it, especially around the timing part. I haven't been able to break my records always under 10 seconds. I wanted to wait for that 5-second time. So food for thought, okay? Extending the framework to something else. We've seen how you can use this framework for security, you can actually use it for other things as well. Okay, we talked about before in the cloud, on-prem, and you can use it for other purposes. Over here, you can think about using that for your cost optimization, for availability, observability, and any other things. You can even take up this framework and zoom in to your Kubernetes cluster. So for some of the gigs on the line that if you run your GitOps kind of process to configure and run your container workload for any Kubernetes environment, you should ring a bell. So because all of your Kubernetes configuration files, their code, that they're stored in the code repository, and you can actually use that as the same as trigger to trigger your cloud, your CI system, such as Cloud Build, and to ingest your policies in that. Obviously, with that, you can't use Kix. Kix doesn't understand Kubernetes yet, but the same process. You can leverage something else called the Open Policy Agent. Look it up. It's a very open framework which you can write similar constraints for other things as well. Now, over here, with the expanding the scope of this particular framework, here's are some examples you can consider. So security, we've seen it. We can look at availabilities as well. So in a GCP, we have Cloud SQL, or in AWS, you have RDS. So one of the things you probably want to enforce is to have the deletion protection. So I don't want people to delete these databases by mistake. Okay, you can then enforce some of the things like a high availability setup, multi-AZ setup for your resources in GCP. We can enforce a memory store, which is a Redis cluster. Okay, the cost optimization as well. You can enforce machine types. You don't want people to go absolutely out like bananas, as an Australian term, absolutely crazy on different sizes of GCE instances, like massive GPUs, etc. And you can enforce labeling of the resources being provisioned in your environment as well. And some of the other things you can hear, just as a food for thought, you can think about how you can expand this framework and also leverage this framework on other places as well. So more than just security, we talked about before, this particular framework is open, and also it gives you the real security. You can integrate that with your different pipelines. It doesn't have to be cloud built. It doesn't have to be anything native. It can be just something you use today, like Jenkins or GitLab. And also it gives you immediate feedback. As we were saying before, if I fail my code, I can immediately have the feedback, why was it failed, and what I could do to fix it. Again, over a long time, you will know how to write a better code, and it can actually give you reduced remediation costs. So you will know what went wrong and the very critical time when it happens. Also, you can automate your detection and remediation. As we've seen before, with a bit of event-driven architecture, like less than 20 lines of Python code, you can actually accelerate the development velocity. So you don't have to wait for different workflow, going to the ticketing system, waiting for security person to check it, and security person talks to your developers, finding out what went wrong, and have a bit of argy-bargy and then fix it at the end. So all of those are gone. It can actually be done automatically in how long? Less than 10 seconds, right? Now, policy as a service as well. We've seen the last part of it. It can be expanded over security realm. You can actually think about writing the policies to control other things, for your infrastructure things, for cost optimization, for high availability setup, etc., etc. And at the end, policy as code. Okay, it's not only that you can codify your policies in this particular example. If you are interested, do a Google search. There's some of the popular frameworks such as NIST, CSA, I think 853 as well. There's an organization in the United States. They're actually turning all of those requirements into JSON format. Okay, so if someone who's got the interest of reading those frameworks, especially 853, it's like massive documentation, hundreds of pages. It says like you shall do that, you must not do that kind of stuff, and all of those actually being translated in the JSON, and that's the future. Because in the future, the whole security enforcement and compliance is going to be code-driven. Imagine a code-driven auditing process. The auditor is not going to bring a spreadsheet with check boxes and ask you for screenshots. Auditors has the JSON formatted compliance frameworks, and the auditors can actually automatically apply that. A very simple comparison of what you have today and what they have as the standard or the compliance framework to see what's the delta. And all of those can happen in a sooner future. So right now is a great time to pick it up, the policy as code kind of concepts. Again, I think one of the key messages I want you to take away today, a few of them. First one, obviously, is the reference architecture. Use it as you can. If you're running on-prem today as well, you can also use it. The second thing I want you to take away is, as you've seen in the demo, with the security in mind, and with the power of cloud in mind, you can actually bootstrap. It can really augment your security capability when you move into the cloud. And also, I understand lots of enterprises are actually on a journey of going to the cloud today. And that's a great place to start. And also, it's a great place to really bring out the security value and to reinstate your security image within your organization as well. Not only that improves the overall security practice, it gives your security team a new brand. It also will accelerate entire velocity of your cloud movement as well. So I think I'm good with the time. I've got 10 minutes left for some of the questions or maybe asking in the chat window. So that's the end of me. I'm going to give the microphone back to Harry and Otto.
Thanks, Ken, for a very interesting, insightful presentation. So I find there's one questions asking earlier, but I don't know if you can catch it up. It's about the timestamp and also the report including in the version number being examined. But if you know which section we're talking about.
Okay, I'm reading now. Timestamp report including version number being yes. So with the security command center, let's say I scanned at the very beginning of this call, it was all good, and I scan right now, it's also all good. So what you can do is to have the report exported to a cloud storage. You can have different prefixes or the suffixes for the different versions of the scan. So you have a full control of different version numbers. You can design. That's with the event-driven architecture. You can definitely realize that. I'm not sure, Choman, if he's still on the call. If that answered his question or her question.
Yeah.
Cool. Good stuff.
Thanks.
I believe Richie, you want to say something, but we can't hear you. Maybe you.
Yes, you're mute.
Still can't hear you. Yes, you're mute. You have to take yourself off mute.
Anyone can also take the time to ask any question if you have. Or maybe as a benefit of the host, I try to ask one question on behalf, if I may. So Ken, you talk about the preventative control solutions. So with the preventative control solutions work for workloads on other cloud platforms?
Yeah, absolutely. So the check marks kicks in the session I introduced today. It actually works for, I think, Elephant Box. It works for AWS. It also works for Azure and even Alibaba Cloud, actually. So if anyone interested, do a Google search, kicks, checkmarks kicks and GitHub, you can actually see the code that's been written for this particular open source framework. And it's written in Rego again. It's written in the open policy agent. So you can do a clone or just copy the code base and make some changes of your own. Because automatically kicks is kind of opinionated. It has the rating of whether it's medium, high, as you've seen before. If you think that's inaccurate or if you think that needs to be changed, you can do that as well.
Hi, I think I can speak right now, so you can hear me. Okay. Yeah.
Yes, yeah.
Sorry that I came late, but it's interesting. Ken, thanks for your talk. We have some questions actually. One of those actually is by me. I just posted it. Based on what you mentioned about the Terraform, it's very interesting, and I would like to know if there's any right now. Based on the form, we can build up the infrastructure according to those codes. Is there any tools which Google can provide or have provide, which can we can say reverse, that is abstract the infrastructure that being built and then convert it back to code? Is there any intelligent tools like this?
I think it's look, because Terraform is a third-party solution from HashiCorp. So it will be a tool provided by them. If I'm not mistaken, there should have been a tooling called Terraformer, like Terraformer. The Terraform provided to take any infrastructure like you probably built using other things like Click or whatever it is to turn that into Terraform code that you can do some further modification. So I think Terraform actually, as a vendor, probably have something similar. It's something. It's not really up to the cloud vendors because Terraform, when you can think of that as a wrapper to manipulate APIs, making things easier for developers. But for some of the people on the line that don't like Terraform, they like Python or even other languages. Google has it, so you can use those languages to write how to deploy IAC. AWS has it as well. So I'm not sure about Azure, but AWS and Google both have that. In AWS, it was called CDK. In Google, it's called Resource Manager, Resource Deployment Manager. So in both toolings, you can actually write your own Python deployment to ask how the infrastructure will be deployed. So it's probably more flexible for more developer kind of infrastructure engineers.
Yeah, interesting. Because some of us may really want to get some of those tools and also really play with it. Another question, which I think we have someone in the chat room asked: does GCP provide on-premises services like AWS Outposts in Hong Kong?
In Hong Kong, so in short, it's yes and. Yes, and okay, let me unpack that for you. So, Outpost is a AWS product. I worked for AWS before. Some of you probably may know. So it's essentially a rack that you put in your data center, and in Hong Kong, if not mistaken, being a very probably freer kind of regulatory requirements and some of the industry is not being that restrictive. So we don't have many Outpost deployments in Hong Kong yet. So in Google Cloud, if you have dialed into the Next 21 conference, which just happened, we have something called the Edge. We have the Google Cloud rolling out. It is not in Hong Kong yet, but if you have a customer who wants something like that, talk to me. We can, depending on how the urgency and how the customer really need that thing, we probably can prioritize. You can talk to me. That being said, though, something is already available today is GKE on-prem. So if you're running Kubernetes cluster, you can use Anthos. You can put it on-prem. In fact, this week we're actually working for one of the telco provider. I can't disclose the name. In Hong Kong, we're running the first ever proof concept in Hong Kong, probably in APAC as well, running the bare metal Anthos. So essentially what we did was we're trying to install Anthos on the bare metal Kubernetes cluster on-prem and having the Anthos in the Google Cloud to control that particular cluster. So that works, and you can also work with anything you're running, GCP, AWS, Azure, or even Ali Cloud, anywhere. So that's the on-prem version of that's already available for Kubernetes and those.
I think Sean, I hope I didn't pronounce the name wrongly. Sean, is it your answer that you want to look for? Maybe you can communicate with Ken later on as well. Okay. Other than that, we have some other questions. One is the question: how does GCE prevent hackers from stealing metadata credentials via the server-side request forgery (SSRF)?
Okay, it's quite a very good question. I think you're talking about the famous Capital One hack. Okay, so it's same thing. AWS at the time I was there, they rolled it out metadata version 2, and we also have similar things over here. So with that in place, even with the server-side request forgery vulnerability, we are going to only provide temporary credentials for that particular session, similar to the same thing as version 2 of metadata AWS. So even that's leaked out, you can't, there's time window that you can leverage that thing for. Again, it's coming back to the good hygiene. If people are familiar with a Capital One hack, there wasn't really a technology hack. It was people probably at the time not being very careful with the IAM settings, right? They've given too much privilege to that particular IAM role that they gave to the WAF. And therefore, when it's talking about blast radius, I think technology-wise, we have it to reduce the attack surface. AWS had it as well. And again, I still advocate for good security hygiene, that having the least privileges for IAM. It's not just native to it's not just specific for the cloud, right? It's on-prem world. We already need to do very fine-grained controls.
Thanks. So anyone have any other questions? Yeah, feel free to ask, because it's a good time that Ken is here, that he can explain some of the very detailed things. I heard from what Ken you mentioned. Maybe let me take this opportunity to ask whether in the coming time, can we try to invite you again to talk about something that you mentioned, the Google, the GKE. Because Kubernetes definitely is one of the very hot topics, and people definitely would like to learn more. And as you mentioned, there are something which is really brand new that happens in Hong Kong. So if you feel if you're happy, we can try to also arrange another in the coming year.
Yeah, absolutely. Well, I can even, because we're CSA over here, I can bring in the security lens of a Kubernetes cluster and how we run it. This particular framework we've seen today, my colleagues in a different region, they're already using it to secure a big customer's Kubernetes clusters using similar concepts. So definitely, I'll be privileged to do that, and it's also a topic I'm very passionate about.
Great, good. I think for the last question, which we have here is, how does the GCP prevent from being hijacked by crypto mining malware? Any idea on that?
So GCP as a platform will not be hijacked. Okay. So you may have virtual machines that you run that's vulnerable to that. Okay. So same as any cloud platform, you have the good hygiene controls, ingress, egress. But since we're talking about product over here, the security command center we've just seen just now, it actually has built-in threat detections, few things it come with, such as detecting any brute force attempt, such as detecting if your virtual machines are actually making outbound calls to suspicious IP addresses, suspicious DNS names. That actually represents the entire kill chain of cryptojacking kind of attack, right? Getting into virtual machines, install something, and trying to talk to command and control center. So all of those events actually can be detected by security command center premium. So that's basically from the detective perspective. Again, I still advocate do hygiene right. Don't don't expose your virtual machines authenticated to the internet, that kind of good stuff. Yeah.
Good. Thanks again. Really, thanks again. The interesting topics. Anything others would like to ask? Anyone? If not, I think we thanks again. And
thanks very much, guys. Good to talk to you.
yeah. And before closing this section, just as for some of the updates about the Cloud Secret Alliance events, we will have another event in the December time, and also we have right now Hong Kong and Macau chapter are able to organize our own set of the CCSK training and CCAK training as well. So if some of you have heard about the CCAK training that's related, that's the jointly developed by the CSA and also ISACA. In Hong Kong, definitely we are able to give our set of the training by around December time. We'll post those updates to our group, and as a Christmas gift to our participants as well. If you join us CSA as our member, when you take those courses, we will have at least $500 discount for you. So it's definitely good for all of you, and you find that the amount is worth more than the membership fee. So thanks again, and thanks Ken again, and also thanks all of you to join the event. Okay, so bye.
Thank you very much.
Thanks so much, guys.
Yes.
Cheers.
Thanks.
Bye.
See ya.
Bye.